Hi, I'm Kristen from the Tulsa Regional STEM Alliance. Today we're going to learn about the field of bionics and build our own bionic hand. Bionics refers to combining the science of the natural world with engineering to create applications in modern technology. Bionics is also called biologically inspired engineering or biomimicry. Scientists often observe, study, and learn from nature, and engineers take and apply that knowledge. For example, the great inventor and artist Leonardo da Vinci studied birds and then proposed flying machines based on what he learned. In some cases, the hulls of boats have been engineered to mimic the thick skin of dolphins. Sonar, radar, and ultrasound imaging is based on animal echolocation. Researchers at NASA's Jet Propulsion Laboratory were inspired by gecko feet to design a gripping system for space. Drone engineers have studied animals like box turtles, bees, and even pufferfish to improve drone designs. NASA engineers have been working on robots that can be used on the International Space Station. The space station is designed for human hands, and creating a robot with the same dexterity and motion of a human is difficult. But if they are successful, a robot will be helpful in performing tasks like routine maintenance of the space station, which would free up the astronauts to perform other scientific tasks. For this activity, we're going to be scientists and observe the workings of our own hand, and then create a prototype of a bionic hand. You'll need some cardboard, like cardboard from a cereal or any kind of food item that you have in your pantry. You just need to make sure that whatever you choose is big enough for your whole hand. You're also going to need scissors. And one thing I like about cereal cardboard is that it doesn't need a special tool to cut it out. You can just cut it out with regular scissors. And you'll need something to write with, tape, some string or yarn, and several straws. For my activity, from the one I made, I used about 5 feet of string and 4 straws. So you'll probably also need at least 4 straws. And if you have it, a wooden barbecue skewer is also very helpful. It's kind of like a giant toothpick. It will help you in threading your yarn through the straws, but if you don't have it, don't worry, you can still do this activity. First, I want you to start by observing your own hand and look at things like where does it bend, and think about what do you think is inside. Have you ever noticed that the back of your hand has raised lines when you move your fingers? Inside your hand are bones, but your hand can't move with bones alone. You also have joints, muscles, ligaments, tendons, blood vessels, and nerves that all work together to help your hand move. Tendons are soft tissues that connect muscles to bones. When muscles contract, the tendons pull the bones, causing the finger to move. And when you look at the back of your hand as you make a fist or move your fingers, you can see those tendons in your hand move. All right, so now you're going to design and build a prototype of your own bionic hand using your hand as a model. And there are different ways to create a prototype, and I'm just going to show you one way, but you should feel free to innovate and try a different solution. This way isn't necessarily the best, and it certainly isn't the only way. First, you want to trace your hand and part of your wrist on the cardboard, and you can ask a friend for help with that part. It's a little tricky when you're tracing your own hand. And next, you'll cut out the hand. Now examine your fingers again and bend your fingers and pay special attention to where the joints are. That's where your finger bends and how many of those you have. And then you're going to draw similar lines on your cardboard cutout, and you can mark these with a pencil or a marker. And then you're going to crease along the lines. So after you draw them, just bend the cardboard along the lines that you just made. Then you're going to cut out sections of the straw, and you're going to tape them to each joint section on your hand. And then for the longer sections of your palm, you'll put a longer straw. So here's some of them that are partially finished. After you have all your finger bone pieces taped, then you're going to thread the yarn through the channels that are created by the straw. So the yarn is going to act like the tendons in your hand. If you have a hard time threading the yarn through, you can wrap a little piece of tape, you can see that, to the end of your yarn, and it'll help keep it from fraying. It's kind of like the plastic tip on a shoelace. And this is where the barbecue skewer will also come in handy because it can act like a needle and kind of help thread the yarn through. If you have a hard time getting the yarn through these long pieces and you don't have a barbecue skewer, just cut them in smaller segments and then you'll be able to get it all the way through. Okay. And then after you've done all the fingers, you're going to tape each tip with a piece of tape. You're going to secure the end of the yarn to the back of the finger so it doesn't pull out. Okay. And when you've got all your fingers done, it will look something like this. Now, I want you to try moving the fingers of your prototype by pulling on the strings. And compare the model to your own hand. How are they similar and how are they different? In a human hand, the brain signals through the nerves to the muscles which contract the tendons and make the fingers move. But in your model, the string represents the tendons, which cause the fingers to move when pulled. Now try to do some everyday tasks with your hand. Can you pick up a soda can or a pencil? How about scratch your head? Try creating a robot hand that can do a specific task. Creating a robot that can function like a human hand with the same amount of dexterity is very challenging. Now think about how you can improve your hand. Our first design is rarely the best design, and engineers spend a lot of time iterating on their designs. Think about what would happen if you used different types of materials like plastic or sturdier cardboard. What happens if you add more fingers or created a model with fewer fingers? I'd love to see what you come up with. You can share your creations with us and tag us on social media using @TulsaSTEM. Thanks for joining me. I can't wait to see what you come up with.